Alright, okay, this is another examples of Newton-Raphson method. Show that the equation 3 ln 1 plus x equals to x minus 1 and has exactly 2 real roots. So hence, by taking 0.5 as the first approximation to obtain the smallest root. Okay, let's go one by one. So which they ask you to show that the equation 3 ln 1 plus x has exactly 2 real roots. Okay, how to showing this has exactly 2 real roots? There's only one way, by using graph, alright, graphical method. So as we know that, okay, let's sketching the graph first, and we adjust such that we can show that there is exactly 2 real roots here. So you can using graph to showing there is a 2 real roots when you show that there is a 2 intersection point. Alright, so you have 3 ln 1 plus x, right? 3 ln 1 plus x. So means that, as you know that you need to sketch the graph for 3 ln 1 plus x together with the graph of y equals to x minus 1, x minus 2 on the same coordinate axis in order to show that they have exactly 2 real roots. So then you have 1 plus x, right? So you know that ln graph, so they will intercept, the asymptote will be -1, right? Do you know why? Because 1 plus x should more than 0, right? Which gives you x must more than -1. The graph is on the right hand side. So as I know the graph is going this way, but I need to find the y-intercept. So the y-intercept for this graph, the y-intercept. So the y-intercept will be x0, right? X0. So as x0, so your y equals to 3 ln 1. Which is give you ln 1 is 0, so it's actually passing through the origin, right? So the graph. So for more accurate, actually you can choose another point here. Maybe you can choose 1 or 2 here, okay? To sketching the graph, right? Maybe I can choose 2. So as when x is 2, right? When x is 2, y is 3 ln. When x is 2, right? When x is 2. So 2 plus 1, 3 ln 3. So let's see what's the value. Right? We just, 3 ln 3, so 3 ln 3. So we're getting 3 ln 3, we were getting 3.3, alright? Around 3.3, right? 3.3. So, so we just roughly sketch 1, 2, 3, right? 4, so 3.3 somewhere here. Then so that we can actually see very clearly how the graph go, right? When we for 3 ln 1 plus x, so the graph will be going this way, right? Going this way. So this is the graph for y equals to 3 ln 1 plus x. 3 ln 1 plus x. So and next we're going to sketch the graph for this quadratic function here, this graph here. Right, this graph on the same coordinate axis. Right, okay, let's continue sketching this graph. Okay, this is just sketching. So we know that this is a quadratic looking at this shape. So we're going to find the x-intercept here. The x-intercept here will be 1 and 2, right? As I equate this to 0. When you intercept x, y is 0, right? So you will intercept at 1 and 2, right? So if you just get, okay, intercept the y-axis. Intercept y-axis, x will be 0, right? X will be 0, right? So x0, so you -1, you have 2, right? So you know that the graph will be moving this way. So maybe you can see that they are actually intersecting at 2 points, right? Intersecting at 2 points. So means that we have 2 real roots. So we have 2 real roots for this equation, right? As 3 ln 1 plus x. This is the graph for, okay, this is the graph for y equals to x minus 1, x minus 2. This y value is not the same, right? They are only have the same value of y. You see that the x value and the y value are the same during this point. X value and y, this is called intersection point, right? So it means that only at these 2 particular points, the 2 value of x such that the y value are the same. So it means that 3 ln 1 plus x is equal to x minus 1, x minus 2 during at this point, right? So this has already shown that the equation 3 ln equals to x minus 2 has 2 real roots. Means they are intersecting, right? So it's between 0 and 1. From here you can see it's between 0 and 1, and maybe this one is after 2, 2, or between 2 and 3. Okay, doesn't matter. So as we just want to know where is the roots, right? Where's the roots now? So now the question here is asking us to actually approximate the roots by taking x equals to 0.5 as the first approximation to obtain the smallest roots. There are 2 roots, right? One will be smallest, one will be biggest, right? So now they're interested about the smallest roots here. So if this is also, you can also use it. Let's say you know that if you're plotting the graph, means that you are exactly using ruler and graph paper, you can actually see the value of the roots of the next roots is within 2, 3, or between 3 to 4 or 4 to 5, right? For now, I'm just sketching, right? So from here, maybe it's after 2, maybe 2 and 3, maybe it's within 3 and 4, we don't know, right? We don't know. So we have to verify, right? But now this question, hence, by taking 0.5 as the first approximation to obtain the smallest root, means these roots. This is the smallest roots. Okay? This one and this one is smallest, right? So this one is the smallest roots. So smallest root and this bigger root. So now we're interested about this root. As you see, it is fall between 0 and 1. Right? It's between 0 and 1. But the question is already asking you to take the first approximation as 0.5. Right? 0.5. So, okay, of course we need the iterative formula, right? The Newton-Raphson iterative formula. So, how to get that the roots, the smallest root, by using Newton-Raphson iterative formula, right? Let's see. Alright, okay. Let's using Newton-Raphson method. Newton-Raphson formula, which is xn plus 1 equals to xn minus with fxn divided by f prime xn, right? The Newton-Raphson iterative formula. So, we're going to see how to using this formula here. So, as I can see here is, we have this equation, right? So we have to make this equation so that one side is 0 here. So 3 ln 1 plus x equals to, as I'm expanding this, I will getting x squared, negative 2, negative x, I get negative 3x plus with 2, right? So then as we arrange this, negative x squared plus with 3x, negative 2 equals 0. I bring everything to one side and equate it to 0. And this will become fx, right? Fx equals to 0. So therefore, I'm going to let fx as my main function for this iterative formula here. So 3 ln 1 plus x minus x squared plus 3x minus 2. And from the formula, I need the first derivative, right? I need the first order derivative. So I just differentiate. So differentiate ln, you are getting 1 plus x, right? Differentiate x squared, you're getting 2x plus 3. Differentiate constant, you're getting 0. So then finalize, and you're getting your iterative formula, which will be xn minus with, so your fx will be 3 ln 1 plus x minus with x squared plus 3x minus 2. And here you have 3 over 1 plus x minus 2x plus 3. Everything subscript n, subscript n, subscript n, subscript n. So this will be your iterative formula, as this is very important, it must be correct. Alright? So how to using this iterative formula in getting the solution of getting the smallest root of this equation. Alright, as the question already asking us to find by taking this, right, they have guide us that as just now from the graph, you know that there is a smallest root between 0 and 1, right? Then there is the biggest root, which is, I don't know the boundary, alright? So, but for now, okay, you can obtain the smallest root by apply this first approximation here, which is 0.5. So you can find the x2 just by substitute this value into the iterative formula here. So it's 0.5 minus with 3 ln 1 plus so on. Alright, okay, I have substitute 0.5 into the equation as x1 to get the x2. After getting the x2, I substitute into the formula again to get the x3. Right? Okay, let's see how to using calculator in solving this problem here. Alright, okay, this will be the iterative formula that we derived just now. So, okay, so as we want to find the value of x2, x3, x4, we can using this calculator, right? Easy. So, and this question, let's say they're asking us to round off to 4 decimal places, right? 4 decimal places. So how to obtain the second approximation, right? So we just key in this into the equation. So alphabet x minus with bracket. So you have 3 ln, right? 3 ln 1 plus alphabet x. So negative with alphabet x to the power of 2 plus with 3 alphabet x. Alphabet x. So double check 3 ln x minus x squared plus with 3x negative 2, right? Negative 2. And below here we have fraction 3 1 plus x, 3 over 1 plus alphabet x, negative 2x, negative 2x plus 3, right? Okay, you have key in exactly the same. Double check, always double check. So be very cautious. So negative x squared plus with 3x, right? Plus with 3x minus 2. So then we calculate, right? Calculate the first approximation suggested by the question, 0.5, 0.5, and double equal 1 time, 2 time. We're getting 0.83, right? 0.83, 0.38, 0.383401, right? 4 decimal places, we give the extra 2. So, okay, let's get the x3. So, calculate answer, right? Using this answer in getting the third approximation, 0.388. 388,662, right? 662. So, okay, if you round off this, you were getting 0.3834, 0.87, so it's still different. So we continue with x4, calculate, answer, so equal again. So we're getting 0.388,673. right? 673. So once you round off, you're getting 0.3887, and this also when you round off, you're getting 0.387. So we stop here, right? Stop here. So as we can conclude that the roots of the smallest root of this equation will be 0.3887, right? 3887. So let's see how to writing the step. Alright, okay, let's continue. We have obtained the value for x2, which is 0.383401, right? And I'm going to substitute this x2 into the iterative formula to getting the x3. Alright, okay, now I have already substituted the x2 into the iterative formula in getting the x3, right? So my x3 value I will get from the calculator, which is 0.388662, right? So it's still got, if you round off this into 4 decimal places, it's still different, right? So we continue to list Okay, after this, the fourth approximation, the fifth approximation, we just list down as we already show how we carry out the iterative formula. So the iteration, so your x4 will be 0.388673. So I think I no need to find for x5, as I can see that these two, after rounding off, you are getting 0.6 rounding off 3887, and this is also 0.3887, right? So it means that therefore I just stop here my x4, and I know that the smallest roots of this equation, this one is 0.3, is x equals to 0.3887, right? So this is the smallest root of this equation here. So it's just to showing you that the advantage of applying Newton-Raphson formula, as the iteration, the number of steps will be not more than usually it will not more than 5 or 6 approximation. It will be very fast converge to the roots.